like I said, what we're going to talk about is data savvy managers, a little bit more, not in detail, but just to kind of give you a reference back from where you started. And then we're going to do we're going to do the course overview, more not detailed like we did on Tuesday, but just more or less how the course breaks out. And then I'm going to do the descriptives, and which mean mode, median range, standard deviation, MERS or Scrum, if you want to throw in correlation, to familiarize, take what you already know, and then familiarize you with Minitab and how it works. Oh boy, everything's working today. Everybody's going, oh yeah, just wait. All right. As we talked, there's so much data out there. There's so much information. If something happens in sub-Saharan Africa, you know, some bus overturns, we hear about it, right? And so we've got data that's being generated on blogs and and databases and data sets all over the world, right? And by Minitab for sure, all right? And so how do we take that information and make intelligence out of it? And that's what this course is all about. Okay. There's Twitter, there's Facebook, there's anybody on LinkedIn? Anybody on LinkedIn? Anybody not on LinkedIn? You got to get on LinkedIn. That's kind of like a big people's Facebook. Okay, that's where my wife actually, a lot of headhunters for people who are recruiting look on LinkedIn for resumes and backgrounds of people that they might have an interest in talking to. And it's not, and all this data that we've got out there, it's not going to get any better. It's an exponential. And right now, just to kind of give you a feel for those who are listening on the tape, sorry about this, but I'll try and describe the chart a little bit. But here you have the beginning of time, okay? And this is the Big Bang right here, right? And then humans came on board here. So there was always some information back here, but there wasn't humans around in order to make that happen. And this happened, I don't know, whenever, all right? And so now, and then we have today, which is 2015. And then we have this thing called the internet that occurred in, let's call it when was Al Gore in? 1996? Yeah. 1996, okay? Everybody heard that one? Al Gore made some claim that he had founded the internet, but regardless, and then you got back here where the PC was introduced, and that was there were some earlier ones, but let's call it 1978, the TRS-80. Right. So now, how has this exponentially grown? Here you have time on the x-axis, and you have amount of data on the y-axis. So what's happened here is there was really nothing here because humans didn't exist, so certainly there wasn't any data or intelligence out there. There really was, but we're going back and we're getting that as the astronomers and people like that take a look at the situation. But regardless, you're coming here, okay, and here's like the Stone Age, and if anybody's religious, Jesus Christ and Allah and Buddha and all these other ones, right? And so as time went on, information was gathered. And how was information gathered before the PC? Yeah, file folders. Boom. That's it. Writings. Yes. The printing press came along. Okay, so we kind of bumped up a little bit back here, right? But then the PC came along, and all of a sudden, this information gathering started increasing rather quickly. And then you hit the internet, and then things started like what they call hockey sticking up. And there are those that believe. Anybody seen the movie Transcendent Man? Transcendence. There are those who believe that by 2025. The human race will be able to begin cheating death. Because if you think about it, you're the sum of all your experiences. And if you can load the sum of all your experiences into a computer, and your experiences were all there, did you really die? Or better yet, we're doing hip replacement, knee replacements, And now they're doing the 3D organs, right? And now they've got they're going to make a heart one of these days out of these 3D printers. I mean, it's just unbelievable. They already think they can do tubes, anything tubing related. A blood vessel can be replicated on a 3D device. Okay, and as time goes on, you're going to replace hips, and so basically the whole physiological, the mechanical, becomes you, and then your conscience is there. That's right. Right. Again, total theory, transcendent man. I forget the guy's name, but that's his theory out there. He's kind of crazy, but hey. Information increases so fast, and science and what have you increases so fast, you never know what can happen. So there's data, and it's growing exponentially. It's in fact, it's kind of a Moore's law sort of thing, where information is doubling every year to 18 months. Just think about all the blogs, all the YouTube videos, all the tweets, all the Facebook entries. That's all information and data. So it's one of the hottest topics, and like we talked before, there's going to be 1.5 million new jobs that are going to be created for people who understand not necessarily what you learned in the basic course, but what you're going to learn in the advanced course, as far as how to take information, manipulate it, make intelligence out of it, and then business recommendations, and gain a competitive advantage. Huge, and there's almost no field that this doesn't touch. I can't think of one. So what we're going to do is we're going to start out with two primary areas. Okay, one is inferential statistics, where we're taking statistics, and everybody's heard of P.05, and we're going to base it on the normalcy curve, and we're going to make some inference about the relationships of data and what it's telling you using ANOVA, regression, chi-squared. So there's going to be about a half a dozen more tests that you can run in order to support your gut or your experience as you're making business decisions or business recommendations, depending upon where you're at in the organization. Then what we're going to do is we're going to pivot. And I know that's starting to be an overused term, but we're going to pivot from inferential and statistics to modeling. Okay? And a big part of that is going to be obviously the Excel models, where you take a business and you create a business model based upon what's occurring out in the marketplace or within your organization. Classic one, how many finance majors, accounting majors, finance accounting majors? Okay, what's the first thing they teach you in accounting these days, right after the sources and uses? Maybe even before that. How to put that stuff into Excel, you betcha, all right? It's all Excel driven. Even the softwares that are developed out of not Tree. What are some of this accounting software? Peachtree, Intuit. All those are based upon an Excel kind of motif, if you will. All right. And so So this is going to be the big transition that's going to occur right around midterm. Is we're going to move, and it's not a big transition. It's just moving from inferential statistics to modeling, and then inserting some uncertainty and risk into the discussion. And we'll use linear modeling. We will use integer linear programming. We'll use decision tree with payout analysis. All these things, but that's another 6 sort of tools or techniques that you're going to have available to you in order to support and help you be better business people. So let's start here. We're going to start with data analysis and inference. And all things data analysis and inference start out with MERS. Mean mode, median range, standard deviation. Throw in C and you got scrum. Right? That's the basics of all things to do with inferential statistics, and it's all to determine, first of all and foremost, do you have normalcy of distribution? So let's go through this. The descriptives, it's a quick way to understand any data set. You can take a data set that's got 1 million terabytes in it. If there's even a computer out there that has 1 million terabytes in there, right? And you can take that information, run it through the software, and out comes mean mode, median range, standard deviation. Some people throw in quartiles, some people throw in some whisker plots, I don't know why I have whiskey on my mind on a Thursday morning. That doesn't, but it's not 5 o'clock yet, is it? No. All right. And then, I'm sorry? It's always 5 o'clock somewhere. There you go. Anyway, so, and then you have two variables, and then you can create a relationship between those variables. And a variable is nothing more than time and data. And figuring out what is the relationship between your x and your y axes sort of situations. Let's start out, and the only reason I'm doing this, it's kind of a refresher, if you will, from last semester, but this is also, I'm going to take the familiar and move it into Minitab where you might be a little less familiar. So what is the mean? Okay. Yeah, but who wants to take this one? What's the mean? How do you calculate the mean? You shouldn't even have to read this. Yes, please. It's Jeff, right? Joe. Okay. That was actually pretty close. Oh, that's what I was thinking. Whoa, kismet. Okay, go ahead. Go ahead. That's right. Very straightforward. And as a result, you get a mean, and you can get a mean for a population, or you can get a mean for a sample. And why do we sample? Who wants to take this one? Why do we sample instead of looking at everyone in a population? Who wants to take that one? Somebody other than Joe. That's right. It's impractical, and you don't need to. In a business, for example, the example I've used a lot. I'm going to move it around to let's move around to India instead of China. How many people are there in India? 700 million. Okay, and if you wanted to find out what all 700 million people thought about the events of Paris, do you have to go out and actually physically talk to all 700 million of the people in India? No. So you take a sample, and the sample size can be at about 1,200. If you work that right, you can. If you work your sampling and your stratify them, and we'll talk about all these a little bit later. But if you stratify correctly, you're going to get a pretty good understanding of what 700 million people feel about the events of Paris by talking to 1,200 people. And anything over 1,200, it's just almost a waste of time and money and effort. So we have X bar, which is the sample mean, which is a point estimator for the population mean. And generally, you're not going to have the standard deviation for the population, so we most always are going to be reliant on the standard deviation for the sample, and therefore we go to a T sort of table if you're under a certain sample size. But that's a little bit beyond this. Actually, it's part of it, but you'll see, remember all the T-tables that you ran last semester? T-tables, Z-tables, F-tables, chi-squared tables. Hopefully you ran those. The computer has loaded all that in there for you, and boom, out pops the information. The median. What's the median? Who wants to take that? Is it Heather? Is there Heather? No. Heather? Yeah. Okay, there you go. Wow, I got it. Yep. It's the median of the highway. Think about the median of the highway. High diddle diddle, right down the middle. Right? There's two sides. There's one going one way and one going the other way, and then you got the median in the middle. So you find the number that's right in the middle of a data set, and it gives you a feel for then you have the mean, then you have the median, and then you get some mode, and then you run in some dispersion. You can, like I said, you can almost understand any data set quickly within 10 minutes, and be able to start working with it. And these are called central location. Now, let's first start out the day. This is the day of the month. We're going into your data set now. That's inside that you've loaded into Minitab, and I've loaded those for you. Hopefully those correspond. Somebody check me if they don't, because we'll change it real quick. So we have 26, 8, 27, 12, 14, and so the first thing we do is we organize these from highest to lowest or lowest to highest. It really doesn't matter. And for 8 observations, you take the number in the middle. Say I did this, 12, 14, and you just organize them up and take the number right in the middle, Okay, but the problem here is you're on even numbers, so you got to take this number and this number divided by 2, and that becomes your median for your data set. Odd number, it's a little bit easier actually. Put them in ascending order, and you got a median of 19. You organize them up. Here's 7. Boom. You pick that one right in the middle. Here's 3 this side, 3 that side. It's the median of the highway. Here's the south side of the highway. Here's the northbound highway side. All right, the median. And the mode. Who wants to take the mode? Somebody else. Austin. Where you at? There you go. Most often occurring. Real easy. What number in all the numbers that you have? Which number occurs the most? Now you have that data set there, and what's the number that occurs the most in that data set that you have in front of you if you open up your Minitab? What is it? 27. Hopefully 27 pops up here. On the next slide. So 27, yay, all right. Whew, the slides work. Okay, so, and you can have 2 modes. You can actually have 3 modes. So if 3 numbers occur 7 times inside a data set, you can have a bimodal or actually a trimodal. Okay, this is one of the reasons that we immediately go to Minitab, is that Excel does not take into account bimodal situations, and certainly not trimodal. It's just a point where Excel is really a nice tool, but eventually you have to move to something a little more powerful, and that's why we're using Minitab in this course. The range, easy to calculate. You take the highest number, this is like the old horse trick. Highest number minus the lowest number. Dallas, on this data set that I'm going to show you here, what's the range of this data set? 18. How'd you know that? It says it right there. Yeah. No, I'm sorry. Go ahead. Go ahead, Dallas. Go ahead. I'm sorry.
Oh, no, you're right. It says right here.
Yeah, but how did you? Yeah, it's really easy. You take the highest number, and the lowest minus the lowest number, and that's the range. Now, what's the standard deviation? What's the standard deviation formula? Anybody got their book with them? Doesn't matter, because we're going to do this on Minitab. And I'm going to stop recording. So we went through Minitab, mean, mode, median, range, standard deviation, boom, just happened. All right, and you're going to actually get a much larger data set. The data set you're going to be working with on your exercise is 70. So you can see where the ability to run it through Minitab real quick is a huge advantage. It just, in fact, it makes no sense to do anything manually. If you're sitting there and your boss says, "Hey, can you give me the median for these 10, the mean for these 10, or let's make it real simple, the median for these 10,000 numbers," and he sits there and watches you go put all these things in order on a piece of paper, you're out of here. No, he's probably not out of there, but he's probably going to go, "Whoa, where'd you go to school?" Right? All right. And standard deviation are measures of dispersion. The metaphor that we've used before is a lake, okay? And who am I calling on that wasn't in the class before? Brenda? Is it Brenda? No. Brenna. I'm really getting pretty close there. Brenna, okay? If you come up to a lake, and the lake says the average, how tall are you?
Like 5 foot.
5 foot. And it says the average of the lake depth is 4 foot 8 inches. And you need to get to the other side. Okay. Are you going to walk into that lake knowing 4 foot 8 inches is the depth? All right. Ah, but it's a long lake. It's a mile long. Can you swim a mile? Okay, let's put it at 2 miles. It's 2 miles. The lake is 2 miles long. All right, so now it's going to be impossible for you to swim that. All right, so now it's the average is 4 foot 8 inches. You going into that lake? You going to walk to the other side?
Yeah.
Why not? A boat. You need a boat. Okay, good idea. But what if I told you that the range of depth was between 4'10" and 4 feet 10 inches and 3 inches? You going across that lake? The range of the whole lake.
Yeah.
Why?
Because I don't know.
Because it never gets over your head.
Right.
Yeah, 4 feet 10 inches is probably. Oh, I see what you're saying.
It depends on how long the range.
Yeah, you can stand on your tip. How tall are you when you stand on tippy toes?
I don't know.
Yeah. All right. Anyway, okay. So if you had a situation where you came across that, you could stand on your tippy toes and get across. Now what? And if I told you the range was 10 foot to 3 inches, now are you going to cross that lake? The range? No. That's dispersion. Okay. The other one is standard deviation. Is how often does 4 foot 8 inches occur? If 4 foot 8 inches occurred 95% of the time across that lake, Brenna?
Yeah, I wouldn't.
No, 95% of the time. 95% of the time, it's going to be below 4 foot 8 inches. You going?
Oh, below?
Below 4 foot 8. 95% of the time.
Yeah.
All right. But the range is up to 10 foot. No, that's the shortest way across. The bridge is out. Good thought. Thank you. No, that's a good thought. Touche. You're right. I'm overplaying the metaphor. I apologize. All right. So, and we've already done this. Okay, create for the apartment rents by location. Yes. Okay, you've got that data set up and running. And so the key here, the only reason, one of the only reasons we do normalcy of distribution discussion is that if you don't have normalcy of distribution, you got a problem, especially if you don't know non-parametric testing. Right? So you have to have normalcy of distribution to conduct these tests. Why is that? All right. Let me do something there real quick. Oh, there it is. So, yay. You want to have a normalcy of distribution. Okay? And the big reason you want to have normalcy of distribution is you want to be able to use the empirical rule, which is all about probability. And you said you would not. Let me ask you this: if it was 99% of the time that lake was going to be under 4 foot 8 inches, and you can swim, are you going? Yeah. So it's all about risk. And that's why you have the normalcy of distribution, because you're trying to understand risk or the probability that you're wrong. Because any decision, there's always a probability that you're wrong. Unless you're a tenured professor, then, But I got ways to go for that one. And so you have your mu, you have your dispersion, you have your range, you have your median, your mode. If your mean, median, mode are all the exact same, do you have normalcy? Yes. So now we talked about normalcy of distribution on apartment rents. That was apartment rents, right? And we thought that it's below 30. Again, these are heuristics, kind of general guidelines, below 30, and we had a skewing of minus 0.2. It's a nice skewing. So there's a normalcy issue here. But in this class, we always assume normalcy of distribution. So now, the next step is I want to talk about correlation, how related two variables are. And you can do this for if there are 20 variables, if there are 30 variables, you can get the relationship between any variable to another variable. And why would you want to know those relationships in an analysis of a business decision? Anybody? Anybody? Because you want to understand those relationships. Is it a positive relationship? Is it an inverse relationship? Is it a strong positive, a strong negative? If you're doing, here we go. Classic one is if you're running an advertising program, okay, and you got advertising on the x-axis and you got sales on the y-axis, and you see that your sales are going down the more you advertise, what's the business decision? Stop advertising. Yeah. But if you see a positive slope, a very strong positive slope, an R value of 0.8 between sales and advertising, now what do? You're pounding away on that advertising. You bet. Boom, 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 boom. All right? Or any program that you have out there. And this applies to it applies to social justice issue, it applies to medical. I mean, it's just everywhere. Okay. And this coefficient, R, it's the R value, a small r, is going to range from +1 to -1. And if it's a -1, it's an absolutely negative relationship. Okay? And anybody want to take a shot at what might be an example of a good thing where negative relationships occur? All right. If the more you sleep, okay, do your test scores go up or down? This is going to be a positive relationship, actually, I suppose. The more rest you get by the numbers, are you going to do better or worse on an exam? Better, right? So that's a fairly strong positive. Now, okay, if you go to the pub the night before, now what relationship do you have? You have a negative relationship, all right? Especially if you get up to around 10 Coca-Colas. And so if there's no correlation, your correlation value R is 0. So now let's go back to your data set, and that kind of finishes up the lecture part.